Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ifram bin Mustafa Kamal. Today I will be presenting about FYP1 presentation of my project, which is improvement of 3D printed robotic arm design, which been supervised by Dr. Zulkifli Mohammed. Let's go with the introduction background. This day, most fabricated industrial robots are in production industry to lessen the labor cost. According to Institute Labor Market Information and Analysis, under Department of Statistics, the minimum wages for plant and machine operator and assembler is 3,809 ringgit for Malaysian and 2,340 ringgit for foreign worker back in 2016. Estimated value for minimum wages for manufacturing labor will keep increase along with the demand for the product. In accordance with the acclamation marked by the world to go forward for Industrial Revolution 4, the usage of robotics and technology in manufacturing sector will be vital, especially for a developing country like Malaysia to follow the footsteps of modern country. Industry 4.0 has presently become known for flexible mass production of elevated retail with decreased period with lower cost. Even though there are some factories had already used robotic arm industry or factories, the objective of the fourth industrial revolution is to be fully autonomous integrated decision-making system like artificial intelligence embedded in the factory deprived of any human interface. Currently, 3D printing generation has begun to seem in production industry. It brings many blessings to people, corporation and governments. Therefore, greater the data is intended to make development or methods to enhance the adoption of 3D printing into next generation. For the summary of literature review, robots can handle things in the way that human cannot, in which involve hazardous, unsafe and repetitive course. There are many conducts to fully utilize the robots in industrial sectors such as material management, fabrication, welding and other repetitive tasks like stacking and discharging utilities. The mechanical layout of the robotic arm is primarily based totally on robotic manipulator with comparable features to a human arm. There are numerous capacity instructions for destiny studies wherein robot machining may be utilized in real international industries. The robotic arm can cover its own orbit as its operating space of mechanical section. Problem statement and objective. This project intends to break down difficulties of 3D robotic arm, constraint effect and outline mechanism. The striving and tricky aim was to locate a technique of development of mechanical structure design to attain the essential fundamental parameters. The prototype exists in a lab have several shortcomings that must be overcome, in which consists of its design. First and foremost, the shoulder of the robotic arm is too heavy and humongous, causing the overall motion being halted. As of its size, it cannot support the elbow to move smoothly, hence render its main objective, in which its movement have to be effortless without any difficulties. Servo motor usually being used in this project as actuators that pivot and rotary also had thrust machinery section with accuracy. Servos primarily used on linear and angular motion for specific speed or acceleration. Back in the prototype, it's mainly used servos as its actuators. On the other hand, stepper motor is better option compared to servos as it provide a better power, attain a slick and accurate flow and at the same time sustain low product expenses. Multiple servos has been attached in prototype generating extra load and burden on the shoulder and elbow parts. Also, 3D printing may be presented in parametric directive of freeform arc. As a result, the essentially anastrophic homes of 3D exposed element may be controlled in this sort of mean that it could be made tougher and more complex within inside the either directive and in particular regions with the right exploitation of the cutting software program. It is not constantly the finest approach to enhance functionality and unravel manageability or other difficulties by combining more degrees of freedom by adding actuators, particularly during the initial layout phases in the starting of the engineering project. For the scope and limitation of the project, in this section there are several limitations that halt the progress of this project because of several aspects of reasons, be it engineering involved problems or not. First and foremost, in order to be able to apply in industrial sector, the robotic arm should be larger. As we all know, to be able to make a huge robotic arm comparable to existing metal-like robotic arm in industry, 3D printer available in faculty lab could make up to several centimeters. This particular project is focusing on a smaller prototype with the same application and parameters, so that even if this project could be emphasized by big manufacturing companies, it can be accomplished without any complication. There are not many samples will be tested, as its ink will be expensive for high quality 3D ink material for a stronger and stable product outcome. Throughout this semester, this project had been conducted in Sports Engineering and Artificial Intelligence Center in Mechanical Engineering Faculty. As ODL had been going throughout this semester, it is very difficult to have a meeting face-to-face with the supervisor, as it located far from home, and a very handful of meeting can be done at UiTM. As for the rest of it, it must be done during the online session to consult and pick up the finest guidance through this entire project. For the scope of the project, this study aims to improve the design of 3D printed robotic arm in terms of material use and the operational program system for the robotic arm as well. For the methodology, this diagram shows the flow of the project from the beginning until the end. There are four main flows of this project, which is modeling, assembling, coding, and analysis. For the modeling, the process is started with the modeling of 3D robotic arm structure using the SolidWorks 2022 software. The pattern part then was straight file to transfer into the 3D printer. Before uploading the file, make sure to examine truthfully the measurement, dimension, and aspect according to the desirable element. For assembling, the properties and part for all the components is assembled, compiled, and applied. The established robot model comprises the major number of variables that influence joint location and consider not only the physical variables such as weight, length, mass, friction, static, stress, and forces. All of the mentioned has been utilized in concurrence with the factual parameters of the robotic arm. For the coding and analysis, in this stage, the process starts with writing the coding for Arduino using its software, and then import the program into the 3D model. Next, after applying the code into the model, assess the robot motion for a simple task. Until the robotic model can fulfill all the simple cores, the coding will be written repeatedly. As to proceed for the analysis, the assessment and authentication of the robot arm is one of the most laborious tasks, as it requires to be repetitive as many as it takes. Usually when analyzing, various difficulties occur, such as incorrect angle estimation, terrible motor adjustment, complication with substantial dimension for angle and point, and one of the servers burned up due to unforeseen excess load. Expected result. The expectation of improvement and development of 3D robotic arm to realize in stable posture hand motion mimicking human arm. The advancement of algorithm of program will clarify the constraint needed to be contemplating attaining steady manner hand swinging flow. The goal is to develop and employ improvement on pre-existing prototype of robotic arm that can fulfill simple tasks as grappling item impersonating as human hand and arm motion, to be applied in many industrial sectors, thus open up a new possible varieties education in other sectors such as education and construction. For the project planning, there are several activities that have been done during the FYP 1, which is choosing the supervisor has been done during the week 1, deciding the topic during the week 2, submission and registration form during the week 3, searching and surveying the academic lecture papers has been done throughout from the week 1 until the week 11. Methodology and preliminary result preparation, producing the proposal has been done during the week 12 and week 13. Submission and presentation of FYP 1 been done in week 14. For further activities for the FYP 2 during semester in the last semester is detailed discussion and preparation with the supervisor from week 15 until week 18. Literature review and conclusion and further work will be done from week 15 until week 27. Final submission thesis and presentation FYP2 will be done during the final week, which is week 28 during this project. I think that's all from me. Thank you.